Cool. Yeah. Unfortunately, at this time, it's also there is another talk super interested. So I'm a bit sad I can miss it also the other presentations. So I will try to make this one nice. I'm Matias Vara. In this presentation, I'm going to talk about the support of ARM CCA and Libkrun. I want to mention also Gavin, that he helped me a lot with the content of this slide. He is the expert of ARM CCA at Red Hat. And yeah, and he helped me a lot to build these slides. So I would like to start to first talk about Libkrun, which maybe you know already what it is. It is a virtual machine monitor for lightweight VMs. It is written in Rust, and it's currently used in different use cases. For example, containers with Podman, play games in Asahi with that, deploy containers with CPU in macOS, and also deploy confidential containers. It has support for a few virtee devices like virtee.net, vSoc, DFS, and so on. And also we have a few TE targets like Nitro, TDX, CEV, and now CCA. And this is the support I'm going to talk today. I'm not going to go really deep in what is CCA. I will just give you a summary about this confidential technology. It stands for Confidential Computer Architecture, and it's the architecture that ARM provides to support confidential computing. It provides for sure encryptation of data in use, which means CPU registers and memory of what they call real VMs. They also allows isolation of these VMs from the host and provides some attestation mechanisms by hardware. Currently, there is not hardware to test this. So what I'm currently using is either QEMU or FVP as an emulator. In this particular presentation, I mostly use FVP, which is something from ARM. But it is also support from QEMU. Just to have an idea what are the different components, software components that are deployed to have a host that support ARM CCA. So we have two words, let's say, the realware and the non-secureware. And to connect both words, what we have is the TFA monitor, which is running in EL3. And then we have, in a non-secureware, Linux with KVM, with a series of patches that currently is in the 10th version, series. KVM rely on a real monitor interface to talk with the TFA monitor. And then at user space in non-secure world, for sure you have the virtual machine monitor. Currently we have today a KVM tool, QEMU, Libkrun, and Cloud Hypervisor that supports to build confidential guests. In the real world, you require Linux with a few patches, which has been upstreamed already since 6.13. The guests rely on the real service interface to talk with the TFRMM, which is a component running in EL2. And I will give you some details about these different components just to have an idea what they do and what this interface do. If you want to try this deployment, you can rely on these two links. The first is based on the string wrap tool, which is something from ARM, which is a nice tool because it's clone all the components, compile them, and run the emulator, so you don't have to do it yourself. In the second link is from Lineario, and it relies on QEMU as an emulator. Either of those links works. In my case, I was mostly working on the first one, using the FVP for emulation. And then using also this tool because I didn't want to clone everything. This tool do everything automatically. Just to have an idea what this interface do. So for example, when the confidential guest talk with the TFRMM, is going to rely on this interface for the attestation and measurement. And also, if you have to change the status of a page from private to share, it's done by this interface. Then, for sure, the virtual machine monitor is still doing the configuring number of CPUs. It also have to define the region that's going to be used for the measurement, and for sure provide the kernel and the MIO emulation. Then, in the KVM, for example, we still have to we're still going to create and destroy the real VMs. Also, it's going to provide the context switching between the real DCPUs and also manage the real memory. So to have an idea, more or less, how is the architecture of the current implementation? So we have Libkrun, which is the virtual machine monitor, and relies on the Libkrun firmware, which is going to contain the Linux with the CCA patches. We also rely on a crate called virtee CCA, which is completely different from Libkrun, and it's something that abstracts away the confidential, I don't know how to say it, the confidential specific. So instead of having that code in Libkrun, what we did is we built the virtee CCA crate, and we abstract away all this in that crate. Let me tell you that as there is the virtee CCA, there is also virtee TDX and virtee CEV, each one for different technologies. And in Libkrun, we include those crates depending on which are the target. And then we have, for example, the chroot VM, which is an application that is included in Libkrun repository that is going just to launch, I guess. It is dynamically linked with Libkrun. And for example, here, just to give you an idea what these apps do, is going to create a confidential guess, or a guess in general. This is the path to the root FS. This is the binary that is going to execute as a first process in the guess. Here I did just a row like this, just to say that this crate could be potentially included by other virtual machine monitor. It's not Libkrun specific. So, for example, in the future, it's Libkrun cloud hypervisor would like to include this instead of having the code in the hypervisor in the cloud hypervisor. It could do it, or potentially other virtual machine monitor. I wanted to give a bit more details about what is virtee CCA. It is part of a virtee GitHub organization that, as I said before, include other technologies like TDX and CEV. It is written in Rust, and it provides an interface to deal with CCA confidential technology. That's, for example, those methods are exposed through this interface. One thing that we have to have in mind is that this interface is not common for all the technologies. It means that the virtual machine monitor have to be specific for the crate that we're going to use. In this case, for some reason, for me, was easy to provide this API, but it's not common through all the crates. I mean, all the technologies. If you want to see more about this, you can find in this repository. So basically, the implementations in Libkrun, we can frame it in 3 groups, let's say. There were the real creation, the memory management, and the memory fault handling and device management. If you want to see a minimalistic implementation of a simplistic way to use the interface that I showed before, you can see this code. It's quite simple. So it's not part of Libkrun. It's just a code that uses the interface that I showed before. It's much more simple to understand how the interface is used to build a confidential guess. So now I'm going to explain this change in Libkrun. So yeah, well, for the creation of the confidential VM, first what we did was for sure use the ARM real flags during the creation of the VM descriptor. You have also to configure what is the algorithm that you're going to use for the measurement. And in addition, you have to set up the max IPA, which is the maximum addressable space for the guest. And this is important because it's a value that is going to be taken into the measurement. I don't know exactly how, but it's, so you have to know it. You have to also bear in mind that the half of the address space is going to use for protected. I mean, for the memory that the guest consider protected, and the other half is for not protected. So, for example, if you use 32 bits, the most significant bits, one means unprotected region. So when you configure the memory of your guest, you have to think that in mind when you calculate the max API. I'm talking from the VMM point of view. Well, regarding the change in the memory management, for sure, we have to add support for carry encrypt guest MD and also for memory version 2. Instead of using MFD for memory allocation, those changes were not part strictly for the support of CCA, but it was for the support of all the TEs. And in particular in CCA, I don't know exactly if it's the same for other TEs, but you have two primitives, populate and initiate, and this is going to tell the hardware which is the memory that's going to use it for measurement. So in general, in my case, what I did was using populate for the kernel, initrd, the NFDT, which is going to like copy memory from the host to those pages that they are marked as populated. And in the pages that they are initiated are those that they are going to be used for RAM, but they are not allocated. So I think I have a picture for that. So basically, when it is signaled as RAM and is populated, all the access go well to the stage 2 page directory. However, for the initiated pages, we're going to trigger a page for like the TFRMN is going to forward to the host and then to provide a fresh page to the stage 2. Let me see the time. Yeah, and for the devices, the only change that we have, as far as I remember, was to expose bounce buffers, which has to be explicitly shared from the guest to the untrusted host. So basically, when we have to do device emulation, we're going to select some page in the unprotected region and then mark it as empty. Those are status in what they call the granular page table or something like this. So those will trigger and carry NSID MMIO, which is going to provide device emulation. But then for the bounce buffer, have to be shared explicitly by the guest. And by doing this, it's going to trigger what they call the carry NSID memory form, which is going to be used in the virtual machine monitor to switch from private to share or vice versa. So it can access to that buffer. So for example, in the case of virtee, you have to share buffers between the guest and the host. And so the host has to be able to read those buffers. And for that reason, you have to switch from private to share. So just to give you an overall status of the support CCA and Libkrun, the PR is under review. if you want to join that effort and comment something, feel free to do it. It has been open since a year and a half, more or less. And for the moment, what I'm using is virtee and virtee console because it's easy to use. For the moment, I also haven't tested until the 9th version of the series. I think they just released the 10th version 1 week ago, but I didn't try it. This has been all tested using the FVP, not hardware yet. And in the case of the virtee CCA, has not been released. I have opened an issue in Cloud Hypervisor to see if someone wants to use virtee CCA for Cloud Hypervisor. And here is the issue if you want to help with that. For the moment, this crate relies on KVM IOCTS and KVM bindings, which are other two crates. But in this case, we are using local versions because the series has not been merged yet. So we have our own repositories with those changes. And now I'm starting to think that could be a good place to manipulate planes in the future. I don't know if you heard what is a plane. They don't have that yet in ARM-CCA, but I think when that comes, the API of virtee CCA should have to take care of that. I mean, try to manipulate those things. I didn't investigate too much regarding attestation. There have been some proof of concept for linear, I think, but I didn't try anything. Yeah, so this is more or less the status of the support. If you want to see a demo, I just uploaded a video to YouTube, when you can see the. I mean, it's not super interesting. You will see just the FVP, and then I launched Libkrun from the FVP. You will see another host like an ST VM, and you can check that you are running in the confidential guest because you can see the log message saying that you are there. So feel free to visit it. I already uploaded the slides, so you can see check the link there. So I think that's all from my side. I don't know if someone has any question. I don't. The question is if the FVP is open source. I think if someone from ARM can correct me, but I think it's not. And what I do is not use it directly. You use this tool, strict wrap, and yeah, and you give command to that tool, and it's going to launch then the FVP. But I don't interact directly with that. Yeah. No. Yeah. If there is no more question, then thank you very much.